with Bryan here. Bryan Eckle is a partner at Summit 2C. He collaborates with clients and leads the consulting team to identify and solve complex problems with clean and simple solutions. Bryan's expertise lies in implementing people, process, and technology solutions to financial management, procurement, budget, and overall data analytics challenges. He's constantly evaluating emerging technologies across data analytics, process automation, and AI and machine learning in order to identify the optimal solutions to the client's business challenges. And with him, we have Dr. Helen Jackson, drawing upon more than 3 decades of practice expertise in physics, engineering, machine learning, software development. Dr. Jackson is currently sharing her expertise as a machine learning engineer with Summit 2C. Dr. Jackson and Bryan, it's a real pleasure to have you with us. Our audience is very much looking forward to your presentation. Thanks for taking the time and sharing it with our global audience.
So good day, everyone, and thank you for attending. Our topic today is pushing RPA to the next level with artificial intelligence, machine learning. And we're going to, I'm going to give a little bit of background. The table of contents, here I'm going to go with some basic things that underlie the technologies. I'm going to define everything that's involved. I'm going to give a path that we've outlined here at Summit 2C for the path to robotic process automation. And then I'm going to talk about what fits under the umbrella of intelligent automation and artificial intelligence and machine learning, which are the components at arriving at this path. And then I'm going to talk about the combination of RPA and machine learning, and then use cases. Okay, so what if you could harness the power of transactional data, harnessing your systems to predict corrective actions in the future? This is achievable with what we call zero to AI. So here's a diagram we've made up. You start up with your data, and as you can see, the data could be any number of forms. Okay, and then and by the way, this is on an AWS platform. Okay. And that in turn is fed into our ML model, which happens to be, in this particular case, AWS SageMaker. And then we get to our endpoint. And when you're dealing with AWS, in order to connect to it, you have to their ML, you have to have an endpoint. And at that point, you are reaching, you are ready to go to your take your predictions to whatever you have, which could be, and for the purpose of this talk, RPA. So I'm going to define the technologies, which probably most people in the audience are very familiar with. Artificial intelligence is actually an umbrella term that covers many of subdomains. Okay, but it describes the broad use of machines to imitate intelligent human behavior in order to solve problems. ML, machine learning, is a technology used to achieve artificial intelligence, usually with algorithms, where the algorithm is able to learn on itself. A subset of that, a subdomain of that, is deep learning, which is a further development of machine learning. There's natural language processing, which is the branch of artificial intelligence that deals with communications, and is actually a colloquialism for all computational linguistics or semantic identification technologies. And then there's computer vision, which is a process of understanding digital images and videos using computers, and it seeks to automate tasks that human vision can achieve. We do use a subset of that quite a bit in document understanding called OCR. Further defining the technologies, IA, which is also an umbrella term, intelligent automation, and it's also called hyper automation and cognitive automation. And it's a combination of artificial intelligence, machine learning, process automation, or anything that is used to create smart business processes and workflows that think, learn, and adapt on their own. Then our key concept here, robotic process information is a form of business process automation technology used to metaphorically used on metaphorical software robots or on artificial intelligence digital workers. And I thought I'd throw in the term IEEE standard 2755 as emerging technologies do need a standard definition and some standardization, and that's the purpose of IEEE 2755. So intelligent automation, very quickly, as I said, it's an umbrella term that can combine robotic process automation with artificial intelligence / machine learning. Traditional robotic process automation is restricted to business rules. Combining it with machine learning increases efficiency. RPA can be a means of injecting AI into legacy enterprise systems, which I think I showed in a previous slide on the path from zero to AI. Your choice of RPA product your choice of RPA product can be married with a choice of a machine learning product in a secure cloud environment. So next, a little bit more on intelligent automation platforms. UiPath has the ability to teach software robots to intelligently process documents using AI. UiPath also has something called AI Fabric for machine learning. However, within UiPath, you can include your own custom machine learning model in UiPath. Document understanding can be achieved via machine learning within AWS and a product of all of these. So again, a little bit more on the definition of artificial intelligence. It can be cognitive automation, machine learning, hypothesis generation and analysis, natural language processing, and intentional algorithm mutation producing insights and analytics at or above human capacity. The diagram that I have on the upper left shows that machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. Deep learning is a subset of machine learning. And I just have a little animation of training going on inside a deep learning neural network. So real quickly on the difference between traditional machine learning and deep learning. One of the main takeaways, if you look on the lower left, given the plot on the lower left, is that given the same amount of data, the performance is much higher with deep neural networks as opposed to traditional machine learning. Also, looking at the diagrams on the right, for machine learning, there are much less hidden layers. Okay, so you have an input layer, a hidden layer, and an output. Whereas with deep learning, you have many more. You can have thousands of layers in between the input and output layers. Now, what machine learning can do is related to document understanding. Well, it can do a lot of things. It's huge, but for the purpose of this discussion, we want to know what it can do is related to document understanding. Machine learning learns from the data. By running it through a given algorithm, predictions or classifications can be made. And this is somewhat similar to the to the slide that I showed of the path from zero to AI, where we're bringing our data into an algorithm here, a machine algorithm, and then we have an output there. Okay, in a system of invoices, it can learn to predict taxonomy features, and by taxonomy, I mean the taxonomy of a typical invoice, for example, can include vendor, amount, date, terms, etc. So the difference between robotic process automation and artificial intelligence very quickly is the robotic process automation, or the robotic processes such as robotic desktop automation and robotic process automation are data driven, whereas for machine learning, they are a simulation of intelligence by humans. On the most fundamental level, RPA is associated with doing, where AL and ML is concerned with thinking and learning. RPA is suitable for automating the grunt work of retrieving emails, for example, and putting them into a defined folder, creating a bill, and then and the accounting software. On the other hand, AI is required to intelligently read the invoices, extract the pertinent information such as invoices, invoice number, supplier name, invoice due date, and so on. A little bit on IEEE standards. I saw a few years ago that there was just a need for standardization in so many areas in artificial intelligence because it was just kind of all over the place as far as defining it. So IEEE standard 2755 has come up with a definition for RPA, which is RPA refers to the use of a pre-configured software instance that uses business rules and predefined activity choreography to complete the autonomous execution of a combination of processes, activities, transactions, and tasks in one or more related software systems to deliver service with human exception management. So although this talk is about the combination of RPA and machine learning, RPA alone has experienced phenomenal growth in the past few years. It has a compound annual growth rate of 29%, and it is projected to have a market size in millions of 2.7 billion by the year 2023. So now let's look at what RPA can do. We can apply RPA to streamline operations and strengthen controls. RPA can jumpstart the transformation process of finance and accounting systems by eliminating manual processes to reduce costs, improve accuracy, accelerate financial reporting, and empower employees. Software robots perform event-driven computer tasks such as what a human does with a mouse or keyboard. It has tools that allow the automation of a series of repetitive tasks. For example, open up a PDF file from an email and enter the data into an application such as Oracle Financials. Run a report out of an application and enter the data into another application. Search for source documents on the website, download them, and then store them into a SharePoint site. One thing to be noted is RPA is not smart. Okay. So, as previously has been shown in previous slides, it can automate processes that are rules-driven, but it is not intelligent or able to learn. An example would be reading the content of an invoice and making a decision from it, as opposed to machine learning, which learns from the data. More on RPA cannot do, which is why this talk is about combining it with machine learning. In another example, currently RPA is not able to handle unmatched transactions, which are those where the invoice amount number, method of payment, or any number of other details cannot be reconciled. It takes humans anywhere from a day to months to track down and resolve these unmatched transactions, and adding up to billions of dollars in unresolved financial activity. So, in the next slide, I am going to give a demo of a side-by-side comparison of the processing of invoices by a human and a robot. So in this case, the human robot will perform the following step. It's going to retrieve electronic invoices from an email. It's going to download the invoice attachments to a folder. It's going to extract billing details from the invoices, PDF. It's going to create bills in an accounting system. We'll just look for a minute or so here to see that the difference in time between the human and the robot. So we see the robot is finished after 3 minutes and 3 seconds. And I'm not going to go all the way to the end where it shows that the human is going to take 8 minutes and 52 seconds. I'll just fast forward the video. Okay, so the difference here is that it took the robot 3 minutes and 3 seconds to process the 4 invoices, where the human took 8 minutes and 52 seconds. Also, in this example, the human made an error when creating one of the bills. Okay, so now RPA and ML. How does the mix of RPA and machine learning fit into intelligent automation? The combination can develop artificial intelligence machine learning models that can go beyond the capabilities of robotic process automation and make decisions about financial transactions. Aided by deep learning, automation of scripts, in some cases, can be accomplished in hours as opposed to as much as months. The mix of RPA and machine learning. So when should machine learning be incorporated into RPA? Well, RPA can build solutions for financial transactions to train a machine learning model that directs corrective actions to robot workers. And I've taken the last part of the slide that showed the journey from zero to AI to show that this is a last part of it here. By combining this ideal mix of working in tandem, significant improvement in process efficiency at much lower cost can be achieved. The AI-based models can be built upon financial data sets and recommend corrective actions in order to improve financial management. So the arrow going back. AI-enabled robotic process automation capabilities will address financial system errors. Another thing that RPA and ML do in combination, and RPA also, is they eliminate the need for a human in the loop used for validation. In machine learning models, validation is built into the model as input data is divided into test, train, and validate. The newly automated machine learning models will be able to take irregular, complex financial information and data and make decisions and apply judgments and solutions to a high level of accuracy or competence without having to have a human in the loop. So now we've gone from zero to AI. So now The next thing that I'm going to do is give some use cases that Summit to C has successfully accomplished. I'll do three of them. First is solving unmatched financial transactions by combining RPA and machine learning. So the goal is to solve unmatched financial transactions by combining RPA and machine learning. Unmatched transactions are repetitive but complex transactions that require elaborate research and decisions, such that billions of dollars worth of unmatched transactions can be outstanding, creating inaccurate financial statements and audit exposure. So here I'm going to give a video, which is on the Summit to C website, showing the combination of machine learning and RPA and UiPath, which is invoking AWS SageMaker to handle unmatched transactions.
To take your historical transaction data, learn from it, and be able to take corrective actions on future transactions. Our intelligent automation solution is a repeatable process where we leverage of historical data from enterprise systems like ERP, feeder systems, etc., to train machine learning models that are able to recommend future actions specific to a business. In this example, we use data from a several SAP systems where unmatched transactions cost over 100 million to collect manually. The Summit solution automates the corrective action with custom machine learning models built on the historical production actions in SAP. For the demo, we've trained our ML model hosted in AWS SageMaker with about 70,000 rows of data. Now, we'll try to get a prediction for these 5 unmatched transactions. Our UiPath workflow will process this file as each of these transactions to our ML model and get a prediction for the action to take on these transactions. Let's take a quick look at our UiPath workflow before we see the action. First, we read the CSV file with the 5 unmatched transactions. Let's go down here. Start processing each line in the CSV file. Select some context from each line. And this is the meat of the workflow, where it invokes SageMaker, where our ML model is hosted. We get a prediction back. And then based on the prediction, we invoke some action. And this action could be invoking another bot or invoking a transaction in another application, or maybe even routing it for human data. Let's go back to our activity where we invoke SageMaker. This is a UiPath custom activity that we have implemented, and it's built on top of the AWS .NET SDK. So you can see that in the left panel here in the activities panel, you can see a prompt, some to see UiPath, invoke SageMaker. Just appears alongside all other UiPath activities. This makes it easy for us to use it in all projects that are using SageMaker. Makes it reusable. For example, let's take a look at the test workflow. And you can see how easy it is to just drag and drop it in here, set up a bunch of properties for it, and now you can invoke SageMaker in there. Let's see about an action now. I'm going to run it in debug mode so we can inspect the logs as we go along. We'll be stepping through the workflow here, and we start seeing the output from each step in this panel over here. So we're at the first step, that's reading the CSV file. And this is where we read those 5 transactions that we need predictions for. We continue. And now we're going to read each line from that CSV file. And the aim here is to pick or grab the data from that line and pass it to SageMaker over here. Okay, we're at SageMaker. Now we get a prediction from SageMaker. It's an obligation. Now, based on the prediction, we're going to take an action. So this action can again be anything you want. It can be invoking some kind of transaction in another application. It could be invoking another bot, or it could be sending it for human review. Let's continue. Now we are at the next line, as you can see from the next context information here. Invoke SageMaker, get a prediction back again. This time it's insufficient funding. And we take action for insufficient funding. We take action for insufficient funding.
So I'm going to stop there. And what this shows is that it's able to make decisions for unmatched transactions.
The next line now.
Okay, so a next use case is accounts payable invoice entry with machine learning. Summit to C created an automation process to process PDF and scan PDF using computer vision and machine learning. The challenge is that inconsistent and varying accounts payable invoice formats from suppliers include PDFs and scanned PDFs that challenge the accuracy of standard OCR capabilities and prevent automation. The solution would be combining RPA with machine learning in order to identify key AP invoice taxonomies such as invoice number, what we've been looking at for the past few slides, address dates, amounts, purchase order number, line item details, without predefined business rules. The data is entered into entered in an Oracle ERP for approval and payment. The benefit is combining RPA and machine learning allows for greater accuracy, less maintenance, and higher return on investment across time. We approach this with achieving the process of varying document quality and accuracy without writing specific rules for changes in document formats. The next slide is going to be AI document understanding, another use case, which is similar to what I've been demoing, extracting data from the PDF invoices, analysis, and update accounts payable systems. And this is built using UiPath AI Fabric platform. So what you're going to see is a bot reads the scanned documents from a folder. It digitizes every document. It extracts the desired attributes like account number, invoice amount, due date, and address. It opens a validation station for the user to validate the details, and it writes the details into Excel. So I'll start this. And I'll run this for a little while, showing how it's extracting the desired attributes. So I will forward this to the point where it's actually putting the information into Excel. So in summary, harnessing the benefits of the mix of RPA and machine learning is feasible on several platforms. Therefore, artificial intelligence machine learning models are able to go beyond the capabilities of robotic process automation, making decisions about financial transactions possible. We have demonstrated the feasibility of going from zero to AI also. Summit to C specializes in delivering data analytics, system integration, and intelligent automation by combining machine learning and RPA. So that ends my part. If Brian, you'd like to say something?
Yeah, thank you, Helen. That was great. Yeah, I think the key there is it's all about the data. So the biggest driver to injecting AI into RPA is getting the right data. And so if your organization has good historical data sets of images, could be database records, could be ERP systems, logistics systems, procurement systems. You can use the historical data in those systems, get that data AI ready by labeling it, and then use that to build machine learning models. Once you have those models, you can easily plug them into existing RPA, business process management solutions, or ERP solutions via those API endpoints.
Terrific, terrific. Thank you, Dr. Jackson. Thank you, Brian, for the presentation. Dr. Jackson, during your video, the audio was a little bit hard to hear on some of the videos, on the YouTube videos that were embedded, but I think people got the essence of the demonstrations that you're sharing with us.
Okay.
There are a number of questions that came up, so I'm gonna bring them up, and if you and or Brian would like to address those, that would be great. The first one that I'm gonna get into, it's a fairly technical one that Misha identified this as one of our participants. She says that UiPath has document understanding and AI fabric, and her question is that why was AI fabric selected and not document understanding for the invoicing processing project that you shared?
Yeah, so I think you saw a couple examples there. The invoice example actually uses AI fabric and document understanding. The Unmatched example was our own custom model, custom integration with machine learning, which was actually done before the UiPath AI fabric product was even released. So that's why you actually saw a couple different ways that you can connect RPA to AI in those examples.
Thank you for that. There's a perfect segue for the next question that comes from Kat, and Kat is asking, would you share your experience with adding your own custom machine learning model in UiPath and how that happens?
Yeah, so I think you saw the graphic there, the 0 to AI. And so it all starts, again, everything starts with data. So it's all about getting the right data. A lot of organizations we work with find that they have very great data locked away in all these back office systems. So those back office systems have captured the data of these very manual, repetitive processes. And if you can unlock that, take that data, label it, get it AI ready, you can use that to create some great training data sets to build ML models from. Once you have the ML model built, you're running experiments, you're picking the best fit, so to speak. And then once you have those built, you expose them via an endpoint, and then you can really connect them to any system, your existing back office business systems. You can use RPA as a connector. You can connect them into existing automation processes or even business process management solutions like a ServiceNow, an Appian, or those type of tools as well.
That's excellent. The next question that has come up is around the cognitive services, and the question is whether you leverage any third-party cognitive services in the work that you do.
Yeah, I think a lot of what we did, we labeled it. So no cognitive services. All of the we do use as far as, I guess, if we're talking about how we build the models, that's anywhere from using Python libraries to there's also some really good auto ML services out there. We use AWS SageMaker, we use Databricks, MLflow. Those are some of the ways we build the models on the data. To build the data pipelines, that varies. We use stream sets, Amazon Glue, those type of things. As far as like process mining tools or things like that, we don't, we've experimented with some of those, but we're not currently using any of those in this solution.
That's excellent. Thank you. And yes, please keep submitting your questions as we have time here to discuss them. Rose Blair had a question related to audio information. Perhaps the question that I would ask is that if you could provide links, I assume those are YouTube links, the videos that are available for consumption. If you could provide links to those videos, that would be quite helpful. And if you're able to do it now, you could put it on the chat, or if it's not easy to get to it now, if you could let our conference leader know about it, and we can send to the participants after the conference when we send them other materials next week. But there's a question about, can I get to the YouTube videos that you share? And I guess the question is, are those public videos or they're private videos?
I believe all the ones we shared are they're publicly out there. They're kind of genericized, so to speak.
Yeah, I have been able to bring them up on YouTube.
Okay, great. So we should be able to get, for those in the audience who are asking about it, we should be able to get you the links for that, and then either through the chat today or later on the post-event communication, we should be able to get those links to you. Very well. The other theme that has emerged on the Q&A is related to the concept of smart robots. People, the RPA vendors, if you will, they have been talking about smart robots for some time, and most of the time is in the context of adapting to dynamic environments, and website changes, and the robot's smart enough to kind of adapt to that new reality. What is different from kind of that dynamic environment adaptation to what you're prescribing, what you're sharing here today?
Yeah, so I think traditionally in RPA, if you're just writing a bunch of business rules, those are very static and don't change over time. If you can limit those business rules or include those business rules in an overarching machine learning model or some type of AI, it just allows your workflows to be so much more dynamic and more resilient over time. That's what we've found. Most of what we've done is really driving dynamic automation related to these back office business processes. So very resilient as to the ability to grab data from an image, even whether it's poorly scanned. And the reason why we can be accurate with that is because we've trained those models using your data, and we've pre-labeled them using the last, let's say, 3 years of your data. So that's made those models very custom to your organization, to the type of data you're getting, and very resilient when they see new data as well.
Excellent, excellent. And one final question here we have from the audience, and this is an interesting one. Natural language processing is an interesting field because I've coming from a semiconductor background. I was always very surprised that it takes a whole lot more processing for natural language than it does for machine vision. For example, the chips for natural language processing have to deal with much more in terms of processing than machine vision, which you wouldn't expect that to be the case. So the segue is that what do you see in terms of an evolution for RPA and intelligent RPA applications? Are we seeing a bit more of natural language processing becoming part of that, if not now, in the next 12 months or so? Or do you still see that as kind of like not a really good fit for RPA applications?
No, I think it's a great connector. I think the text, either text or voice interaction with these automations is crucial, a very important component. And so that's the NLP piece of that is a vital part of it, absolutely. So I think it just depends
and I like to
on.
Say that,
yeah, go ahead, Helen.
I like to say that in the applications that we're developing, the machine learning for document understanding, that we do combine computer vision usually in the first steps, and then we do natural language processing. We do some combination of it. So because of the fact of the identifying the text accurately. Go ahead, Brian.
No, I think that's a good wrap on that. Thank you.
Very well, very well. Well, ladies and gentlemen, our time is up here. I want to say thanks to John Driscoll, who actually found the videos on YouTube, has already posted as a question, and I replied to everybody. So before I close the session, look into the message that I sent, which was a reply to John Driscoll, and he has at least one, the human versus RPA bot invoice processing video link is in that answer. So copy that so you have at least one of the links already. And I want to thank again Dr. Helen Jackson and Bryan Eckle for being here with us. Tremendous view of what's going on in the world of RPA and intelligent automation. Thanks for sharing your expertise with our global audience today.
Thank you, Jose.
Thank you for having us.
Thank you, ladies and gentlemen. That was Summit to See Leadership sharing the greatest insights from RPA, machine learning, and artificial intelligence. Of course, there's so much more that we can talk about, and our time was limited, but I hope that you got some good insights from that, and there is much more to learn. We're going to be wrapping up the session, and at the top of the hour, you're going to be meeting me back here, and I want to talk about digital transformation, business transformation, and cultural transformation. There is no successful digital transformation without business transformation, and there is no successful business transformation without cultural transformation. So we're going to talk about the elements of excellence, innovation, acceleration in great enduring organizations. How do they blend ideas, methods, technologies, and the people to achieve great enduring performance? So it's going to be a higher level presentation on what C-level teams are focusing on to change and adapt in the decade ahead. So I'm going to be sharing that benchmark with you at the top of the hour. I hope that we can engage at that time, and looking forward to our interaction. So closing the session for now. See you back at the top of the hour. Thank you.